First of all, I'd like to introduce myself. My name is Gregory Wallace. I am the P3 branch manager for the production line. Solution elements. One of the things that we had to do was we had to focus on WIP reduction in metals. We had to definitely do that. We had to bring everything back to one central location within the hangar deck. Once again, we had multiple aircraft being worked outside of the hangar, and it was putting a strain on all of our resources. So basically, our solution elements was, number one, WIP reduction in metals. We definitely had to reduce the amount of active aircraft that we had in metals. The second one was execution management. Execution management was used to stabilize the flow of aircraft and increase predictability. That was one of the things that we definitely had to do. WIP reduction. Basically, WIP reduction was putting aircraft on hold, concentrating resources, execution process, creating transfer decisions, and release points for the aircraft. Now, I'm pretty sure that this is the standard WIP reduction that you all have followed inside your organization. So let me go to some of the actual details. Putting aircraft on hold. One of the things that we had to do was we had to prioritize the aircraft. We had to determine which aircraft was closest to being completed. We also took a look at part availability, and also we took a look at the customer's requests. We had to take a look at all these different variables in order to determine how to prioritize the aircraft. So basically what we did was we immediately put 4 aircraft on hold. Remember, we had 10 aircraft being worked in metals. We immediately put 4 aircraft on hold. That left us with an active WIP of 6 aircraft located in metals. Now, there was one aircraft, it was sequence 520. That particular aircraft had very limited resources that was needed in order to complete the metals phase. So we elected to go ahead and keep that particular aircraft in work because we felt that since it had limited resources in order to complete the task, we could go ahead and focus on that aircraft and push it on out. So we actually put 4 aircraft on hold. Now, putting these aircraft in hold, all of a sudden, it freed up the valuable resources that we needed. You know, one of our key constraints was resources. So by putting the aircraft on hold, all of a sudden we had the trained, skilled artisans that we had been looking for. So basically what happened was those freed resources were allocated to active aircraft. We moved to a balanced 3-shift operation. Okay? We created teams for each metal cell. It was a mixture on each team. Basically, what happened was each cell had 9 artisans assigned to each shift, a total of 27 artisans. We also created what was called a Tiger team. This Tiger team was very important. One reason it was important is because it actually contained highly skilled artisans and some trainees. These particular artisans were actually utilized in the metal cells whenever an artisan was in training or didn't show up for the day. We were able to pull resources from the Tiger team and put those artisans to work to help those cells continue to aggressively complete the aircraft. The Tiger team supported both the metal cells and the assembly cells. These were highly skilled, trained artisans. Execution process. One of the key things that helped us out was this process here. Every morning at 7 o'clock, we had what was called a daily walk around. One of the things that we wanted to do is keep the supervisor focused on the aircraft. We didn't want the supervisor running around trying to put out fires, trying to resolve issues. We wanted him at the aircraft, managing that particular aircraft. This was very important to us. We had a group of dedicated managers that actually participated on the walk around, and every single day we went to each metal cell and we actually tried to make sure that all the issues that they had was resolved. One of the things that we actually created within our organization was a sense of urgency. If there was a problem, that problem was dealt with immediately. One of the things that we would make sure is before the beginning of the next shift, we had a commitment to resolve that issue. If that issue had to be elevated up to the highest level within our organization, that is what we did. We made sure that the issue was resolved before the beginning of the next shift. Transfer decisions. Basically, we use transfer decisions for control release points. We made sure before an aircraft was moved out of the metal cells into an assembly cell that all the required work was completed. One of the things that we didn't want to do is release an aircraft to assembly with artisans still hanging on the aircraft performing tasks. So we made sure that before we would release that aircraft, there was a transfer decision. We made sure all the resources were in place, all the tasks were completed, and the aircraft was actually ready to move to the next process. This is also something that really helped us out. Basically, what we did was we created a criteria for the release point. We made sure that all the open inspections were completed. We ensured that all the material and parts were available. We ensured that the paperwork and the documentation was there at the aircraft on day one, and it was correct. And we ensured that the aircraft had the proper resources in order to start work on day one. Okay, releasing from whole. Once again, maintain a WIP level of 1 in, 1 out rule. That was the process. We made sure that an aircraft was released and we actually pulled in an aircraft. Basically using what we call was the pull system. In the past, we had been using the push system. We were pushing aircraft on top of aircraft, trying to get them through the process. So we started using a pull system. As we release one aircraft, we would pull the next aircraft in, something that definitely helped us out. We also, once every 2 weeks, we reviewed the WIP levels with senior management. We made sure that we were maintaining the rules of critical chain. That is very important. One of the things that we really tried to do at FRC Jacksonville is change the mindset of all the individuals. We wanted to make sure everyone clearly understood the theory of constraint and critical chain. Aggressive TATs. Unidentified work scopes made the T80 estimates very difficult. Remember, this was a process that no one had ever done in the world. We were the first ones to do it. We had to develop the process as we went through it. Utilize engineering requirements and experience to estimate task durations. Now, one of the problems we had here with the old system that we actually used is there was a lot of safeties built into the time. When I say time, I'm saying the process time. So we had to get people away from the mindset of billing in safeties, because from years of working on aircraft, when you go and ask an artisan how long it's going to take to do a job, he's going to make sure that he bills safety into that so the aircraft is completed when he says it's going to be completed. So we had to get rid of those safeties. We only had so much time to produce these aircrafts, so we had to make sure that we got rid of the safeties. So one of the things that we did was we cut the task times and we created a buffer in order to meet our TAT. The turnaround time was 220 days. That was the amount of time that we were given to turn these aircraft around, 220 days. Okay? And understand, once again, no one had ever done this before. That was the time that we were working against. So we actually created a buffer of 74 days. We basically took 33.5% of the total TAT to create the buffer. And may I point out one thing, using the buffer is not a bad thing. Okay, priorities and execution. This is something that really helped us out here also. Now, once again, Concerto was the tool. We changed the mindset of the organization. We focused on critical chain and the theory of constraint. That was the focus. That is what we wanted everyone in the organization to understand. They had to change their mindset if we were to succeed. Using the software alone cannot help you. Okay? You have to change the mindset within the organization, and critical chain is the key. So one of the things that we actually done at the facility was we created task descriptions. The task description was basically a roadmap for the supervisor, understanding these are new processes. So the task description actually created a roadmap for the supervisor. The supervisor would come in, he would know exactly what his tasks are for the day. He's not trying to plan 60 days out in the future. He's focusing on his bucket of work that he needs to accomplish within that day. So we wanted to make sure that the entire organization was focused on the task at hand, not the task that's required 60 days down the line. We also created a column here that was called Skill Needed. It was a skill needed column that we created. One of the things that we had to deal with was all of the aircraft that were in metals at some point in time needed a support task. We needed to develop a way where all of the support skills would understand what their true priorities were. So by using this system here, it's kind of hard for you to see, but there was a skill needed column. So what would happen is in the morning, once the work had been started for the day, if the supervisor needed a particular special skill, he needed a qualified tail person or a plumber or a painter or a machinist to perform a task on his aircraft, he would go into the skill needed column and he would put that task in there. What that would automatically do, it would flag the entire organization what the skill needed for that particular aircraft is, and everyone understood that those skill needed tasks are worked in priority. If you look on the left side of the screen here, there's a color scheme there, red, yellow, and green. Basically what that does, it indicates how much of the buffer is being utilized for that particular aircraft. So once again, we created the skill needed column that set the priorities for the entire organization. We created a task description that the supervisor could use as a roadmap because this was a new process. We also had a column that was called work stop barriers. If for some reason the supervisor ran into what was called a work stop barrier, it would also be indicated in this system here. And it was another way to flag the entire organization on what the requirements were for that particular aircraft. And we had a rule that all tasks were man-loaded. That was the only true way that we could accelerate the pace. You have to man-load your task. So what would happen is the A shift would start out with the task, the B shift would follow up, and then the C shift would come behind them. And at the beginning of every shift, there was a requirement that there was communication between the two shifts. There was a 30-minute overlap where the two supervisors would come in and sit down in a room, and they would go over the task for the night. Then they would go out and they would make their assignments. Results overall, we had actually projected to increase our throughput from 6 aircraft to 9 aircraft by the end of September 2009. That's a 50% increase. Now, when all of this started, we had only looked at possibly doing about a 35% increase. We actually were able to project a 50% increase. So by September of this year, 2009, September the 30th, we would have produced a total of 9 aircraft. That's a 50% increase. We were previously only producing 1 aircraft through metals a month. 1 aircraft a month. The overall WIP is projected to reduce from 14 down to 12 by the end of September 2009. That's basically a 14% reduction. And all of this was achieved by running a 3-shift operation, following up tasks from A, B to the C shift, and accelerating the aircraft at the very end. Metals result. We had projected to increase the throughput from 6 aircraft to 9 aircraft by the end of September 30th. Once again, it's a 50% increase. Metals WIP had been reduced from 10 aircraft down to 5 aircraft. That's a 50% reduction. Now, at the end of September 2009, September the 30th, we had to induct 4 aircraft. We were financially obligated to induct those aircraft. So what that actually is going to do is it's going to take our WIP back up to a total of 12 aircraft. Increasing predictability. Once again, buffers accurately project your delivery date. One of the problems that we had is we were using a pulse system. We had about 14 pulse dates, and the entire organization was operating under pulse dates. Everyone was trying to make a pulse date. You know, whether the aircraft is complete or not, I made my date, I pushed it down to the next guy. The buffer trends actually help substantiate the projected date. What we found out was by using the buffer system, it allowed us to see early in the process when we were not going to make our schedules, or if something was not being completed in a timely manner. It flagged us early. It's an early warning system. You don't get to the end of a project only to find out that you're not complete. So by using the buffers, it allows you to see that there is something wrong early in the process. It's been very helpful for us. A balanced role on the core team with daily responsibilities. When we first started with Concerto and the theory of constraint, one of the things that we did not do is all of the core team members were not fully dedicated to the team. Only half of the team was. And what we found out was this was really a full-time job. In order to implement this process correctly, we had to make sure that they were dedicated to the team. They didn't have to worry about their main job for the day. Okay? Key people understanding the role of priorities earlier. This was also important. As we were pulled out of our positions to actually participate on the core team, we created a vacuum, basically. And one of the things that you have to be aware of is make sure that everyone within the organization understands the priorities very early in the process. Setting task level priorities early can lead to delays. One of the things that we tried to do was, prior to us implementing the software, understanding this was new workload for us, we wanted to try and set the task level priorities a lot early in the process, actually too early. That's something that you have to be very careful of. The only reason we tried to do that early up front was because we knew it was new workload. There were some supervisors that had never gotten to a certain point in the process, and we wanted to kind of lay the process out for them so they could understand the sequential order and how things had to be done. Limit multiple tracking systems. That was something that we had to get rid of, basically. Was the command had so many different ways to track the progress of an aircraft everyone was using a different program. So we had to all use the same program. And also correctly staffing the sales and the Tiger team. When we first started out, we did not correctly staff the sales and the Tiger teams. We had to make sure that the resources were spread out and balanced throughout all the cells. Some of the cells were really stacked with highly qualified people. Some of the other cells were not stacked with highly qualified people. So it's a balancing act. The core team members could not make it here today, so I wanted to definitely acknowledge all of the members. Tim Knowles, he's the Deputy Program Manager. Hank Sims, he's the Support Branch Head. Rodney Boone, he's a Production Specialist. Willie Barton, he's also a Production Specialist. Keith Smith is a Hub Scheduler. Diane O'Brien was our Process Engineer. And Eric Hayner is also a Process Engineer. I'll also like to thank the organization that I work for. One of the keys with setting up this process is you have to have support from senior management. And I can truly say that the command, Captain Soul, senior management supported us 110%. That was very important. They came to our meetings, they were involved, they were engaged. That really helped us out a lot.